All right, guys, today we're going to do 5.6, which are inverse trig functions. So you can see the warm-up. Go ahead and do that one. Pause the video and then restart it when you're done. All right, so we have graph sine of x. So we go to y equals, we're going to do sine x, and we're going to do inverse sine x. And then part 3 was, are they reflections over y equals x? So what I'm going to do first is just go to my mode. I want to be in radian mode so that I see a full cycle every, 2 pi or 6.28 versus every, 360, right? That would be a huge graph. So we're going to go to radian mode to keep it a little bit smaller for our x coordinates. And then I'm just going to hit zoom 6, I guess, for now. And then we get this graph that looks like this. So that's sine of x. And then that right there is inverse sine x, right? So that sine to the -1 we read as inverse sine x. So are they reflections over y equals x? Well, no. I mean, not really, because this shape is completely different than this shape. But if you think about it, right, it's like this shape, if you reflected this over y equals x, right? So I'm going to do a third one as y equals x. We'll graph that. If you reflected the blue one over that line, if you can kind of imagine folding your screen in half, you would get a vertical line that would, not a vertical line, but the curve would be much more vertical. But then your calculator can't graph that because your calculator won't graph anything that's not a function in this setting at least. So it's kind of a weird thing because technically the answer is yes, they are reflections, and we can see that if we just condense this. So if we just look at an x value of, we'll just say, we'll say -2 to 2, and then the y value is between -2 and 2 as well. I'm going to get rid of, well, I'll keep it there and see if it looks okay. But this is sine x right there. And then this one is inverse sine x. And what you can see is they actually are at least partial reflections over the y equals x axis. Now, if you can think about why does this stop right here? Well, because this is like almost the top of the curve on this part. So if you started continuing it, it would turn back this way, and then it wouldn't be a function anymore. So it just graphs what would technically be a function. So that is inverse sine x. So they actually are reflections over y equals x. It's just only a really small part of it. And that's kind of the answer. So as we can continue here, this is just y equals sine of x, right? So basically, if you think about inputs and outputs and what you've been working with functions, the input, sine of x, right? The input is an angle, right? You're going to input some sort of, either in degrees or radians, some angle in there. And then whatever it spits out is the ratio of, y over r for, if you can think about the unit circle on that point, right? So we can draw our unit circle to help us out. And then we can even put lines through it so we can model like a unit circle, just so we can see it, right? So if I said f of, right, pi over 2, so I'm plugging in pi over 2 for x. So sine of pi over 2 would be the angle, right? So right there to there. And we know that sine of pi over 2 is going to be 1, right? Because it's 0, 1. So sine of pi over 2 is 1. So f of pi over 2, right? F is the function, so you're just plugging in. This should actually say f of x, not y, but basically when you plug in pi over 2 for x, you get something that's equal to 1. So the x-axis, which is always what you plug in, right? It's called the independent variable. Your independent variable in these questions are angles, right? You're always plugging in an angle. So the x-axis represents theta, or the angles. And then whatever it spits out, so all of these y values are side ratios, which in this case are sine values. So the y-axis is the trig ratio, right? So trig ratio, which in this case is sine. So you notice that all of your y values are between -1 and +1, which should make sense. Oops, +1, right? It goes to that line. Which makes sense because if you think about all of the y values for your unit circle, right, the lowest y value is -1 and the highest is +1. So it makes sense that all your trig ratios are something between -1 and +1. So again, this is just graphing regular sine of x. It has nothing to do with inverses. So when we're doing this, we are finding the trig ratios given what we plug in is given, so that's the independent variable, given angles. So I'm just going to say theta, right? And that's basically what you would do with a problem like this. That's not an inverse, though. The inverse would be the inverse operation, which, if you remember from inverses, you flip x and y. So now, if you had f of x or y equals inverse sine x, that's how we read it, they're going to flip, right? So what it is now, this may look confusing, but the x-axis, if you flip the x and y, now the x-axis from the previous question is the same thing as the y-axis. So the independent variable, what you plug in, are the ratios themselves, right? So -1, 1, √3/2, whatever the number is. You plug in the ratio in for x right here, and then what it spits out would be, as you may have guessed, the angle. So all of your answers here are going to be angles. So if I said f of 1, I am plugging in a ratio where y over r, because it's sine, will equal 1. And the radius is always 1 if we're going to use a unit circle. So basically the y coordinate is 1. That's that same point on the unit circle right here. So basically it's saying, okay, we know that the final spot is right here. What angle gets us there? Well, that is pi over 2 if it's in radians, right? It's 90 degrees, but we didn't graph it in degrees, we graphed it in radians, so it's pi over 2. So again, with inverses, you're actually finding the angles given the side ratios. It's the same thing as the one before, it's just that the variables are flipped. And so it's a different process. It's almost like backwards thinking. I'm going to give you the ratio of the sides, you're going to give me the angle. So now if you're thinking, well, Mr. Jocelyn, that's pi over 2. Yes, you're true that that does end in the same terminal spot. But what about -3 pi over 2? What if we went this way, right? What about -3 pi over 2? Is -3 pi over 2 an answer? Yes, it is, right? So pi over 2 is just one angle that's going to have a sine value that's equal to 1, but there's an infinite number of them. -3 pi over 2. If you went all the way around, 2 pi plus pi over 2, I think that's 2.5, so 5 pi over 2, that ends in the same spot. That also has a value that's going to equal 1 if you had plugged it in to the other way. So there's an infinite number of answers here. Which is an interesting thing, but if you think about the calculator, there's not an infinite number of answers, right? So if you plugged in 1, f of 1, you get, right there, only one answer, right? And it's about 1.57, which is only pi over 2. So if you tried, but if you kind of could extend this graph and just pretend that it made this shape the whole way through, it would also hit 1, 3 pi over 2, which would just be a lot higher than what I graphed. But there's a reason why we only graph a small part of it, because it's only going to be a function for a small part of it. So pi over 2 is correct, but technically -3 pi over 2 or 5 pi over 2 are also correct. Not 3 pi over 2, because that will give you a y value of -1, which is not what you want. Okay, so because there's an infinite number of answers, we have to restrict all of the potential answers into something that's called principal values. And this is really where your calculator comes from. Because again, you notice this red one, which is the inverse, it does not continue forever. Because if it did, it would no longer be a function. It would start curving this way and this way. So we have to cut off all of our values, right? Our x values, which in turn cut off all the y values, to only certain numbers so that we only have one answer for every question instead of an infinite number of answers. So if we think about sine of x, right? This is, again, not the inverse. This is just the original. You have to think about, okay, all of the y values, if you remember like a horizontal line test, the inverse won't be a function. So this does not pass the horizontal line test, right? It intersects in more than one spot. So we have to cut this graph off in a spot where every single y value is still included, but it doesn't start to repeat, right? So, if you think about, let's say we're going to cut it off between pi and 2 pi. Well, that's a problem because these y values repeat, which means if you graphed it as an inverse, the x values would repeat and it wouldn't be a function, right? So we want to think about, spots where it wouldn't repeat y values, that way the x values don't repeat, but that it also covers every single y value. So if I just thought about, well, why don't we just cut it off between pi over 2 and pi? Well, that's great. None of the y values repeat, but you don't get all of the y values, right? So you don't get any negative y values between pi over 2 and pi. You only have positive ones. So we don't want to cut it off there. So if you're thinking, where could we cut it off? This isn't a bad spot between pi over 2 and 3 pi over 2. Again, none of the y values repeat. So pi over 2 is here to 3 pi over 2 is here, right? You get every single sine value, because sine is y over r. So you get every single sine value from there to there, but that's actually not where we cut off the principal values. If you think about the calculator, it went from, right, the y value is like negative 1.5 to a positive 1.5. Well, it's actually not 1.5, it's 1.57, which is pi over 2. And that's kind of where we cut it off. So for sine, we restrict all of our principal values for our inverses between negative pi over 2 and positive pi over 2. So negative pi over 2 would be like this angle right here. And then it would include every single y value from there up to positive pi over 2. So again, it's just this side of the circle instead of this side, but the lowest value we can have for our principal values would be negative pi over 2, and the biggest one is positive pi over 2. But again, if you think about sine, every single y value, so every single sine value is included within this range. You don't even bother with these two quadrants, again, because if you extended it, it wouldn't be a function as the inverse, right? If you started including more stuff, it would start curving back this way. And it would open up multiple answers for questions where there really only needs to be one answer if it's within the principal values. So that's the principal values for sine. So we're going to restrict all of our answers between negative pi over 2 and pi over 2. Cosine is different, right? If you think about cosine, if you restricted all of your values between the same negative pi over 2 and pi over 2, right? And you just used, okay, it's just the answers, it's just the numbers that exist within here, it wouldn't work because cosine is x over r. So whatever x value is right here is the exact same x value as right there. So you're repeating x values, which wouldn't be good because then you would have two different angles that would have the exact same inverse cosine value, which is not what we want. We only want to have one. So we actually don't want to break the unit circle up by those angles. So here we're going to look at a graph of just cosine of x, not the inverse. We're going to look at where do we have non-repeating values, right? So again, pi over 2 to 3 pi over 2 would not be good because now you only have negative cosine values, which makes sense because pi over 2 to 3 pi over 2, all of your x values or cosine values are all negative, so we don't want to restrict it there. And again, for the same reason that they would hit twice in certain things, so that's not good. So if you're thinking about a good spot where we could do cosine principal values, it's actually between 0 and pi, because if you think about between 0 and pi, if you looked at the graph of cosine, it has all different output values, all between negative 1 and 1. So if we started at 0 and went to pi, which is right there, we have every single possible cosine value right there. Because cosine is the x, so you have x values all the way from negative 1 to positive 1, and that's everything. We don't go anything into these two quadrants because if we did, then we would just be repeating x values that already exist within this principal values right here. So the domain restriction for cosine values, right? So the principal values for cosine are between 0 and pi, or 0 and 180 degrees. right? If sine would be negative 90 degrees and positive 90. And those are the only two, I mean, there's 4 trig ratios, but those are really the only 2 principal values. So tangent, if this is the graph of tangent, now this one looks very different because it's y over x. So you don't have to have everything between 0 and 1. Y over x can be, infinity if it's like a crazy small denominator or something like that. But it's kind of the same idea where we're going to grab parts of the graph where we contain everything in a curve. So for tangent, we are actually going to take the same thing as sine and say, okay, we're going to look at between negative pi over 2 to pi over 2, and every single tangent value is included in here. You have your positive tangents up here, and you have your negative tangents up here, but these 2 ones are ignored because whatever tangent value is right here is the exact same tangent value of here, so we're already covered. So we don't bother with quadrants 2 and 3. So again, that's between negative pi over 2 and pi over 2. There's actually a small difference. The only difference would be, like right here, if you had y over x right there and right there, whereas sine, y over r would be, 1 divided by 1, so you'd get 1 right there for sine. With tangent, it's different because y over x, the y coordinate's still 1, but it's not 1 over 1. It's actually 1 over 0 because that's where the x coordinate is. And here it would be negative 1 over 0. So that's undefined. So this one, it's still between negative pi over 2 and pi over 2, but it can't include those. Like you wouldn't put them in a bracket, it would be in parentheses because those are not included because those would be undefined. But as sine, it actually you could plug in negative pi over 2 and pi over 2 for an inverse because it wouldn't give you an undefined angle. It would just give you negative 90 degrees or positive 90 degrees. But here you would have to say these are off limits themselves because they're technically undefined right there. And then cotangent would be great if it was the same thing as tangent. And you could argue that it really could be because cotangent values are going to be negative here and positive here. But if you think about the shape of cotangent, if you did negative pi over 2 to pi over 2, I mean, if you think about it, you do get every single value, right? But it's just not continuous. We're going to try and break this up into one continuous thing so that we don't have to worry about, having it try to make sense graphically. So instead, we actually ignore this part for principal values, and it's the same thing as cosine, where it's just going to be 0 to pi. So cotangent is 0 to pi. So all of your positive cotangent values still come in quadrant 1. That's true for all of them. But your negative 1 cotangent values actually come in quadrant 2 versus tangent where they came in quadrant 4. Even though they're the same ones, we want to be able to use a continuous curve so that in the middle it's not undefined. In the middle it's actually just going to be 0. Which if that didn't make sense, again, cotangent is x over y. So if we looked at pi over 2, x over y would be 0 over 1. That's okay. We don't want to have, we want it to just be continuous. Now what's not technically included are here and here, whereas in cosine they were included, but here x over y, because the y's are 0 right there, would give you undefined. So again, it wouldn't include these. You'd probably use parentheses instead of brackets. But that's it. And then the other two kind of just follow the same thing as sine. So sine was negative pi over 2 to pi over 2. This is the same. And cosine, or secant is the same thing as cosine, just because, again, those deal with the x values just like cosine. So you're going to get all your different x values from here to here. Whereas cosecant, you get all your different y values from here to here. And those are principal values. So exactly what are we doing today, right? Now that we got that out of the way, I'm probably more confused than ever. What are we going to do with this, right? So here's a typical question. Inverse sine of 1/2. Again, it's an inverse, right? So it's basically this 1/2 would be, that is what the ratio equals. So y over r is going to equal 1/2. So that just tells you the y coordinate's 1/2 and the radius is going to be 1. So 1/2 over 1, same thing as 1/2. You could picture this as a non-unit circle and just say it's y is 1 and r is 2, and then you can go that way. But for us, these are always going to be points that we're probably going to be familiar with. So your 1/2, your root 2 over 2s, your root 3 over 2s, 1/0, things like that. So it keeps the question a little bit easier for us. So just always think of the r as 1 and then just, okay, say y is 1/2. So where is your y coordinate 1/2? Well, that's 1/2, so it's like right there. And you also have y as 1/2 over here in quadrant 2, right? So these are the two spots where your y coordinate is 1/2. So again, your answers to inverses are going to be angles, right? Inverse means you're looking for an angle. They both begin with a vowel, I guess. So if you're thinking what angle would end right there, well, 30 degrees does, right? So 30 degrees is an angle that would end right there with a y value of 1/2. So that's actually your answer. Now if you're thinking, well, what about 150 degrees, which would end right there, y value is still that same 1/2, whether you look at this point or this point. But this 150 degrees is not within the principal values for sine, right? Because if you remember, we said sine was between negative pi over 2 and pi over 2. So 150 degrees, which is the same thing as 5 pi over 6, is not within the principal values. So normally for questions like this, I would specify your answers need to be within principal values. Otherwise, 150 degrees is fine. But that's it. Now, if you're thinking, well, what about negative 330 degrees, right? Or negative 11 pi over 6. That same thing, that would end right there. The terminal coordinate would be, y value of 1/2. But negative 11 pi over 6 is still not between, it's not physically a number between negative 1.57 and 1.57. It's much bigger, or much smaller actually, because it's negative. So even though it's the same spot, you're only looking at 30 degrees, or only because it's probably in radians, it's going to be pi over 6 radians, right? So that's the only answer, even though there's an infinite number of angles that will end right there with that terminal spot. There's only one answer because that's what principal values does, right? So on your calculator, if you did inverse sine of 1/2, which is 0.5, you will get whatever that, so that is right there, pi over 6. Right? And if you change the mode over to degrees and did inverse sine of 1/2, as you may guess, you get an answer of 30, right? Because it's just going to be 30 degrees. So that's that. So what I want you guys to do now is just pause the video and do these 3 questions, and then we'll go one more slide, and that'll be it. That's enough for today. All right, so if you've done these ones, right, it's principal values only, so there's only going to be one answer. So this is inverse sine of negative 1/2. Again, the question is asking us what angle, because it's inverse, will have a y value, or y over r value, but r is 1, of negative 0.5. So negative 0.5, a y value could be right there. Again, it could be right here, but sine is just between negative pi over 2 and pi over 2. So we're going to ignore this one because it's not in the principal values. So we're only looking at this angle right here. So if you think about it, right, well, we've done this angle for a while. That's 330 degrees. Well, 330 degrees is not between negative 90 and 90. Or 11 pi over 6 is not between negative pi over 2 and pi over 2. So what we need to do is actually change our answer so that we get the angle that goes from here to here, which is negative pi over 6. Because that is a number that is between negative pi over 2 and pi over 2. So negative pi over 6 or negative 30 degrees if you did it in degrees. Cosine of 3 pi over 2, right? Or inverse cosine of root 3 over 2, sorry. So again, I'm looking for an angle where the x value, or x over r, is root 3 over 2. So an x value of root 3 over 2, that's your long side. Same thing as a y value of 1/2. Could be here if it's in quadrant 1, but you know what? It also could be here in quadrant 4 in that exact same spot. But again, if you remember, cosine's principal values are between 0 and pi, which excludes anything over here in quadrant 4. So we're actually just looking at this angle right here, which is pi over 6, or positive 30 degrees, right? And that would be the only answer. You couldn't get a different one by going negative or going all the way around and hitting there or anything. Lastly, we have cotangent, which is -1. So again, I'm looking for an angle where the cotangent value, which is x over y, is going to be equal to -1, right? This is a little trickier, right? It's actually not one of these quadrantal spots because those would involve sine or cosine, because those are like x over r or y over r. You have to think about x divided by y is going to give you a value of -1, right? So it's got to be the same number divided by itself to give you a value of 1, and if that kind of rings a bell, that's going to be root 2 over 2. So x is going to be root 2 over 2, and y is going to be root 2 over 2, because those coordinates go with each other. Now the question is, which one's negative? Because it's a -1, right? So this is where, again, the principal values are going to be helpful, right? I'm going to do this one in green, because that will tell you which quadrant you're in. So for cotangent, same thing as cosine. So you're between 0 and pi. So if you think about it, the fact that it's negative kind of tells you it's not in quadrant 1. So it has to be in quadrant 2, because that's where you can have a value for cotangent. It won't exist in quadrant 4, which it would be negative, but that's not within the principal values for cotangent. So it's going to be in quadrant 2, which tells you that the x-coordinate is negative and the y-coordinate is positive. So that would be a negative root 2 over 2, positive root 2 over 2 would be right there. So what angle, is between 0 and pi? That goes right there. So that's going to be 3 pi over 4. Or in degrees, that would be 135 degrees. That's pretty much it for the lesson. We're going to get into more, but we'll wait till after break. The only other thing that might pop up is that word arc, and we'll review this when we get back to, but arc basically means inverse. So if it says arc tan x, it means inverse tan x. And that's all that it means. So arc tan of root 3 would just mean inverse tan of root 3. And we'll continue this when we get back from break. But